Hello, welcome to Gecko Coding. I'm Dylan Miles, and today we're going to be talking about abstractions. Okay, so abstractions are essentially symbols that represent something, but they're also not the thing themselves, and that's quite an important concept. So let's have a look at one example, and let's just start with the letter A, for example. The letter A is actually just a graphical symbol. It's a shape, but it does hold meaning, and that meaning is based on some sort of agreement. For example, because we both speak the English language and we've gone to school and we've learned the ABCs, we all know, we've all got some association with the symbol A as to some sort of meaning. For example, that it's the first letter in the alphabet. And it has the sound, it represents a sound like ah. Okay, but actually, on its own, without this meaning, it is just a shape. It is just a symbol. It's not actually the thing itself. Like the A is not the sound ah. It represents the sound. So that's important. It represents the thing it's representing. Okay, let's have a look at another example. Let's have a look at actually a word. For example, flower. This is a more composite symbol in that it is made up of individual letters, which are symbols in of themselves with their own associated meanings. And then the word as a whole is also a container of meaning itself, so it also forms a symbol. And if you look at the word itself and you look past the letters or at a high level, it's actually just a shape. Again, it's a graphical representation or symbol of something. Of what? And I mean, if you go out into your garden, you might be able to see one of these, but a flower. And again, even this picture is a symbol of a flower. It's not actually a flower in of itself. It represents a flower. So interesting. It could also have other sorts of associations, like things like implied meaning. For example, it could imply beauty, or some sort of invoke some sort of emotion. So that symbol itself of the word flower is a container of a lot of different kinds of meaning, and depending on how that symbol is used, could convey different parts of that meaning. A last example is just of a map, and I'll try to draw a map of the world here. Let's just maybe draw some representation of Africa. We've got something, Europe, maybe some Asia here, India down here, and that is a map of the world. And we might also then put, for example, a city there, or let's put it on the end here, called Cape Town. And this world map is not, this is a symbol of the terrain of the actual world. So if I go to Cape Town, I'm going to see a very different view of Cape Town. I will see the Table Mountain with maybe the cable car over here, and the city with the buildings, etc., etc. So it's a very different view. And if I visit Cape Town and I actually go to the city, I'm experiencing the city directly, whereas when I interact with the map to find out where I'm going, then I am interacting with the symbol. Okay, so in terms of what is an abstraction, it's simply a symbol that represents something. But it's not the thing itself. Okay, to explore the question of why to use symbols or why they're important, let's look at symbols in the context of software development. So let's say I have a piece of text, and let's just call that piece of text word. So it is a word itself. It's actually the symbol of itself in this case. And that's a piece of text that we pass into a small program that is going to capitalize that word into capital letters. Something very simple. Okay. Then we're going to feed that word into another little program called abbreviate. And out is going to come the piece of text WRD. Okay. So here what I've done is I've described the functionality of a program, of two programs, but I haven't gone into any detail on what those programs or how they're doing the thing. I've just described what they're doing, and I've used symbols to represent them. So a box with a C in them is the symbol I'm using to represent a program that capitalizes a piece of text. You give it the word, and out comes capital letters word. But there's a lot of detail that might go into writing a program that capitalizes text like that. But I've hidden that detail behind a symbol. So now I can work with this symbol in relation to other symbols at a high level without getting stuck in the detail of how capitalize actually works. And that's very useful because it helps with conversations about meeting needs. So just make a little bit of space here on the right. And typically when I'm having the conversation about what a program is doing, I'm typically interacting with a client. So another person, and let's call them client. Okay, and we're talking about meeting that client's needs as to they want a program that turns a piece of text like this into Word, but they really don't want to know how it does that. Okay, now I get another person in the mix, and that person is, let's say, the software architect. So he's got a kind of and also let's say BA is at this level as well. They've got to try and come up with some sort of approach to actually writing the software. What is the design of the software going to look like? And in this case, it is quite simple. We're going to have, we're just going to again use a set of symbols to describe the program, but we're actually going to expand on what this little block is doing in a bit more detail. And firstly, we're going to have some sort of memory structure. That holds the data word. Okay, we're going to feed it into a loop, or a loop is going to consume that. So I'm representing the loop with a symbol of a little circle with an arrow here that's going to read off a character at a time from, in this case, the input. I'm just going to call that in using another symbol in. I'm going to be reading off character by character. Each character, I'm going to take the small character that I get from this array, and I'm going to make it into a big character, an uppercase. And then I'm going to write that out into another array or another stream of data, the capital letters, WORD. each character one character at a time. And there I've used another set of symbols to describe the program a little bit more pictorially. I've expanded on the meaning of how we actually going to approach the writing of this program. And this is a conversation with the architect, the BA, and the dev are all going to have some sort of input on this diagram. And then this program will need to be implemented. And that's probably a developer who's going to write the actual code to do that, which again is another set of symbols using a programming language to represent this. So in our case here, that's going to be, going to use a fairly high level language, which is there is largely based on English. So some of this might be quite familiar for non-programmers. For each, and I'm just going to use the letter C for each character in, and let's call this, this is input or standard in, and this is out. So we just call these streams by their names. For each C in. Okay. So that is that in, and this in is a keyword in the programming language that I'm using to say that for each character in this stream, what do I want to do with it? I want to append it to out, so out.append C dot to upper. So C.to upper is going to convert this character, whatever this character is. In our case, let's say it's W. Going to convert it to uppercase, and it's going to append it to the output stream. And this for each is a loop. So this piece of code here is it's going to run again and again each time I'm looping through the for loop until I've read through all the characters available in the stream. Okay, so another part just to discuss about abstraction. So here you've seen why it's useful. Another important part is the ability to navigate between these layers. So for example, if I'm having a discussion with the client, it's really pointless for me to be at this level telling the client, oh, we're just going to use the to upper function. It has no meaning for the client. All they need to know is there's a way to do it. And so navigating levels means that if we're talking to this audience, then we are discussing at this level using this level of symbol. If we are working with the dev, at times we're going to be talking about actual code and syntax and whether our compiler is able to compile it, or whether we're getting errors, or whether they're runtime errors, etc., etc. How are we going to package this code? If we're talking about overall approach and what other systems we're interacting with and the types of data structures we're using and things, we're talking at this middle level. So it's very important to be able to, in your mind, context switch between these different levels, between these different abstractions. There's one other point around abstractions as well that's quite important, is that as powerful as they are, I mean, that you can represent a whole world within a symbol like this, is that number one, you have to have agreement. So you both have to share some contextual meaning of that symbol with whoever your audience is. So that's one aspect of it. The other aspect is that you can get caught up in the symbol itself and forget about what you're actually trying to achieve and become almost obsessed with the symbol itself, and therefore lose track of what you're actually trying to achieve. So a good example of that is when, especially among software developers, is when they get hooked on a particular language or whatever, a particular technology that's going to solve all their problems, or a particular language that they think is going to solve all their problems, and they don't look at the actual, or they forget about the actual purpose or the need that they're trying to meet for the client, and they get caught up in the detail of, for example, the coding language itself. Well, thank you very much for watching this presentation on abstractions. Just to recap, what we covered is what is an abstraction, and really it's a symbol representing a thing, but it's not the thing itself. We discussed why it's useful, and it's an essential tool in communication, and how to navigate the different layers of abstraction is an essential skill within software development, to be able to communicate between different stakeholders in a solution. And then we also looked at some possible pitfalls that to avoid when working with abstractions. So once again, thank you very much for watching, and I hope you enjoyed it, and I'll see you on the next video. Please subscribe so you can be notified of the next video, and hit the like button. Bye bye. Have a lovely day.